Hi, hi, uh, hello, and welcome to the second lecture of the first week of this Programming and Data Structures course offered by NPTEL. And the response to the first lecture has been very nice. I found that people on the forum are very active, and there are many questions and exchanges of thoughts. I have a couple of comments to all of you who are actively participating on the forum. Um, there are small, uh, I would not say bugs. For example, loose programming practices. For example, many of you will recognize the fact that I had kept the range of a certain variable, a counter variable, to be one more than exactly what is necessary. Now, these are specifically given so that when you count the number of comparisons, you will, for example, note that those are not necessary. So therefore, you should trust in your understanding and use your logic to convince yourself that your approach is indeed correct. That is one. And the second point that I would like to draw your attention to is that read the question carefully, and I think the questions are fairly well phrased. And once you once you understand the question and understand it properly, the answer is fairly straightforward. So, by today, uh, by the end of this lecture, by the time you get to see this lecture, there will be a short description of the first activity which will be available to you on the portal itself, on the forums. So, I look forward to your comments. So, many of these are self-assessment exercises. They do not carry marks. They do not carry weightage for the final evaluation. So you do not have to worry about how many marks you will get and so on and so forth. And like I keep saying, enjoy the subject and leave the evaluation uh, to significantly later when you're comfortable with the subject material. All right, having said all these things, let's move on to the lecture for today. So, we're going to talk about structures, pointers, and functions. These form the central pieces in the understanding of how to design and maintain data structures. I repeat, you need to be able to work with structures, you need to be able to work with pointers, and you should be able to write functions which will manipulate these structures and pointers, and this is what forms the central um, and these three form the central concepts to work with data structures, and that's what you will be exposed to in today's lecture. Of course, you may worry about why we are learning all this in C. I think C gives you a flexibility of the richness and the level at which you can program. So, I mean, if you work with a feature-rich programming language, then you may really not appreciate the challenges of designing your own data structures. On the other hand, C is a very flexible programming language where you can implement your own data structures at almost any level that you wish to challenge yourself. Right? So we will today review concepts in C about structures, pointers, and how to manipulate them using functions. Like in the earlier lecture, there will be a part uh, where we will work with real code, and hopefully that is useful. So I look forward to comments on that on the forum. So now I'm going to take you to the PowerPoint presentation. All right, so structures, pointers, and functions. Here we go. Okay, so what are structures? Those of you who have already programmed in C to a certain extent will realize that a structure is a syntactic feature given in the C programming language. That is, it is a keyword. Struct is a keyword that is given to you in the C programming language where you can group variables under a single name. And these variables can be of different types. As you see on your screen at the moment, you see an example of a structure called student details, which has 5 fields. The 5 fields uh, are important as designed by the programmer, okay, to represent some details about students in general. And the fields are first name, middle name, and surname, which are designed to be character arrays of size 20. There is a bit of a syntax error that has been deliberately introduced there. So, for example, here, so where the 20 is associated with a character, it's some kind of a pseudo code just to draw your attention. When we look at the program, all this is cleaned up. Then we maintain an integer, which is the year of joining, and we also maintain a single character which represents the gender of the student. Now, the most important thing is that as a programmer, you think of this as a template for every student, right? But as a person who is going deep into programming, the most important thing is what you see here. A new data type called student details is created by the struct keyword in the C programming language. So therefore, using struct, you can create a new data type. Now, after creating a new data type, you can define variables of this data type. As you can see here, student1 and student2 are 2 variables whose types are struct student details. Therefore, the concept that you need to keep in mind is that we have created a new data type. We will delve deeper into what it is to create a new data type as we go on in this lecture and in the subsequent lectures. So, however, when I say you've created a new data type, you have created a user-defined data type, putting together variables of different data types. So you will naturally have this question saying, can I put together other user-defined data types to create another user-defined data type? The answer is yes. I do not have examples for this today, but these will definitely follow in the next few lectures. Okay. How does one use a new data type? Let us just take a look at these. Let us look at the simplest of assignment statements, where to the field year of joining in the variable student1, we assign the value 2015. Observe that year of joining itself does not have any meaning unless you say in which variable the value year of joining has to be modified. In this case, we say that student1, in student1 year of joining is assigned the value 2015, and the dot delimiter is used to say in which variable the corresponding field. Right? We can also assign the variable student1 to student2, exactly as we assign variables of other basic data types which we are familiar with. Now, when you want to copy a string into the field name in the variable student1, we use the string copy command. The string copy command is present in the string library. For this, you need to include the header string.h. Then you can, like every other data type, print the appropriate values that you want. Here is a printf that does this. Now comes the interesting thing. So these 4 points were really about how to use a variable of a new data type that you have created. In this case, how does one use variables student1 and student2 of the data type struct student details that you have just created, right? And those are the things that we have seen. We've seen that you can perform assignments, okay? And you can copy a string value into the appropriate character array. You can print the corresponding string. Therefore, all these assignment operations can be done. However, the thing that I have not written here, but I'm sure you're aware of this, that you cannot perform comparison operations between student 1 and student 2. If you wanted to compare the contents of student 1 and student 2, you must compare field by field. That's not written here, but I hope that was clear. Now we come to the next concept in this slide, which is the concept of a type name. Recall what we've done so far. We've created a new data type called student details. Actually, that's not correct. We've created a new data type called struct student details. Now, this is a very cumbersome or a very difficult thing to keep typing as a programmer. Therefore, the C programming language allows us to create a new type name. And the new type name is called student record. And the statement in red, which is type def, this is a keyword. Struct is a keyword. Student details is the name of the structure that we have defined in the previous slide. Student record is a shortcut for struct student details. I hope this is clear. Therefore, for a programmer's comfort, a new type name is created using the type def construct. There are a little more details about type def, but however, as a programmer, as a starting point, it's useful for you to understand that you've created a new type name and you have said that the type name student record from now on stands for the new data type struct student details. Okay. How do you use this? To define variables, for example, I've given the most interesting definition, right? So I define a pointer to student record, and the pointer is the variable student pointer. So therefore, so far we have seen that using the struct keyword, you can define a new data type. When you define a new data type, you say what are all the different data items which constitute that particular data type. Again, you specify the basic data types there. And then for the programmer's comfort, you create a new type name. This is a very useful feature, and let us see how to use these in the subsequent slides. But at this point of time, you should be aware of the fact that you can now define new data types. Now let's just stop for a minute and ask, how many data types do we know now? Okay. So, well, we know characters, we know integers, we know floating point data types, we know double precision, right? And many of these also have type qualifiers. For example, you must have seen signed integers, unsigned integers, signed characters, unsigned characters, long and short type qualifiers. These are qualifiers that are associated with the data types character, integer, float and double. This course is not about the data types, but you can definitely learn about these from a C programming book by picking appropriate applications. And definitely we will design appropriate assignments so that you will get to use all these features. So you may have to enter into a steep learning curve to be able to program. Now the question is, what are the data types that we can create using struct and pointers? Even more, why do we need pointers? So observe that pointers are also a data type. An address, right, is a data type, and though we will not delve into this, right, so whenever you define a variable to be a pointer, right, so the pointer data type, the pointer to an integer, pointer to a character, and in the previous slide you would have seen pointer to student record. So the pointer to different data types by itself is a data type. I repeat, the pointer to a data type is by itself a data type by which you can create variables of that particular data type. Example, observe that student pointer is a variable, and if somebody asks what is the data type associated with this variable, the answer that you have to give is that the data type of this particular variable, student pointer, is a pointer to student record. I repeat, the data type of the variable student pointer is a pointer to student record. Therefore, the pointer to a data type is also a data type. You will become familiar with this concept as you go through this course, But I hope if you have a confusion, go back to what I have said earlier and it should become clearer. Okay. So therefore, what is the subject data structures? Many people have posed this question on the forum, right? And I'm answering this question now. The subject data structures is the study of the design of user-defined data types. I hope this is now clear. If somebody says he or she is studying data structures, the picture that has to come to your mind is that this person is designing new data types, right, and using those new data types in different programs. Right? Now, what is physically a data structure? Observe that the previous statement was about the subject data structures that you study. Now you can ask, what is a data structure? To define a data structure, I will say what a data structure contains. A data structure contains data. Okay. Now, what kind of data? Data of different types, and in particular, I will say data of a user-defined data type. Now, this is not completely correct because integer and character and float and double are not user-defined types. But in this course, when you study data structures, you will be creating your own types. Therefore, we will be creating data structures which contain data of types created by you or types created by me. Therefore, you can now visualize a data structure to be something that contains data of a certain type. Now, what are important properties of data structures? Right? So the first part is very clear. A data structure contains data. Now, if you ask me data of what type, I'll tell you, look, the most important thing is user-defined data type. Then you can ask me, is it only user-defined data type? Then I'll tell you, no, you can also have data of integer type and float types and so on, which are provided by your programming language. Right? So therefore, data structures contain data of different types. Right? The subject becomes very interesting when you start trying to create your own data types. What more do we know about the data structure itself? We wish our data structures to be dynamic, in the sense that we want to write our program so that the data structure can grow and shrink at runtime. That is, as your program runs, your program must be flexible enough to be able to maintain data which grows in volume for a certain amount of time. Right? That is, it is processing more and more fields, more and more data items. And after some time, as the processing gets over, it also shrinks periodically. And we will see applications. Now you will ask, how does one write such programs? That is the focus of this course. Right? I hope this is now clear. The summary of what we have discussed so far is that we know that the struct keyword in the C programming language allows us to define a new data type. Okay? The type def keyword allows us to define new type names as a shortcut for programmers. We also know now that there are many data types that we know, and for the rest of this course, the most important data types that we will repeatedly encounter are user-defined data types created using struct, and very importantly, something that I have said I think 4 times, and I'm going to say this the 5th time, that pointer to a data type is a data type by itself. In other words, pointers are data types, addresses are data types. Now, using the freedom to create new data types, we will now write programs which create and maintain data structures. In other words, we will write programs where the data of a particular type that we are maintaining can grow and shrink at runtime. And we are going to see how to achieve this. Therefore, if a data structure has to grow and shrink at runtime, somehow we should be able to get memory from somewhere whenever we need it, or whenever the execution needs it. We should be able to put in instructions so that at runtime the program will not only execute your arithmetic and logic instructions and assignment instructions, but we need to also put in instructions which will demand memory from the underlying execution environment. It may be the operating system or whatever. It doesn't matter. You can think of this as an abstract person who is giving memory as long as it is available to your program when the program is executing. Fine. So now Pointers play an extremely important role in enabling data structures that shrink and grow when the program runs, otherwise called runtime. Like I said a little earlier, a programmer codes these instructions to ask for memory, and it is also important to return memory at runtime from places when it is not important. Right? So for example, if you're finished using a certain amount of memory that was dynamically allocated to you, it is a good programming practice to return that memory using appropriate instructions when you program. Now you can ask, what are these instructions? Right? So are these instructions keywords or are these function calls? The answer is these instructions are function calls. These are functions which are there in the C library, and for these you must include stdlib.h. In all these I am assuming that you are programming in a Unix or a Linux like environment. However, if you are programming in other programming environments, other underlying operating systems, you may have to find out what needs to be included, and you can post such questions on the forum and we will see if we can answer. Okay, so you need to make library function calls, and what is the result of these function calls? You can ask for a certain amount of memory and you can also release the memory that you have finished using. And remember that these are function calls that you write into your program. When you compile and run, these functions will be executed. The result of these function calls is that you will get memory and you can return memory. Now, three of the functions that we will study are called malloc, otherwise called malloc, and free. These are the two functions that we will study in the lectures. calloc is another function that you can study by yourself, right, which is called contiguous alloc, calloc, but we will not really talk about it. Alright, malloc or malloc and free. That's what we are going to talk about, and these are really the functions that give our programs the power to grow and shrink, to maintain data structures that grow and shrink at runtime. Alright, so let us look at malloc. Right? And this slide is a heavy slide and you may have to go through this a couple of times, but it is a complete slide. It has everything that you need to know about how to use malloc. Right? Okay. So let us just see. Student record is the data type. Don't forget that this is a new type name we created in the first slide. Example is a variable, and just to ensure that you don't forget, example is a variable of what type? You should try to answer it yourself, but the answer is that example is a variable of pointer data type. Okay, pointer to what? Pointer to student record data type. Right? So example is a variable that contains the address of a location which contains data items of the student record data type. I hope this is clear to you. Then n is an integer variable. This should not be confusing at all, and the way we are going to use this is that we are going to use n as the number of data items of student record type that we want. So I'm going to use n as a measure of size. Size of what? It is going to be the number of data items of student record type that I want to ask. I'm going to ask for that much amount of memory. I'm going to ask for n units of memory in the next statement. Alright, so let us just look at the statement. The statement reads, it's an assignment statement. On the left hand side of the assignment statement is a pointer variable. Right? Example, it is supposed to store an address. And the right hand side, right, is a function evaluation. Right? So now let us evaluate the function from innermost function call to the outermost evaluation. Right? So the innermost is this function called size of student record. Size of is a library function. Right? And what is the input argument to this function? The input argument to this function is a type name. So for example, you can write a small program which says size of int or size of char or size of float. Right? So therefore the argument is a type name. Size of is the name of the function. The value is the space in bytes to store one data item. Right? Now, I am not going to tell you how much space student record is going to take. You can calculate it, but that will not be the exact number. This varies from compiler implementation to compiler implementation. But you can get an approximate understanding. If your data type has one integer field alone, okay, so let's say it has two integer fields, then you know that student record must have space to store two integers. Right? So you're right. However, for a variety of other reasons, student record is often slightly larger than the estimate that we will make by adding up the amount of space required for each of the individual fields. Right? And the reason has to do with the subject of computer organization, how memory is accessed, and so on and so forth. So we will not delve into exactly what the space used by student record is. However, sizeof is a library function that takes a data type name as an argument, and the value that it returns is an integer, a positive integer value, an unsigned integer value, which is the number of bytes required to store this one record. Okay, and now I have an expression which said n multiplied by the result of the sizeof. So I am demanding, using the malloc function, I am asking for n units of the space required for one student record. In other words, this malloc, n multiplied by size of student record given as the argument, essentially asks the system for n units of space, each unit being the space to store one student record. Okay. Now, what does malloc do? Malloc returns a pointer. In other words, malloc returns an address. Right? You can imagine that malloc goes and asks the system saying, give me space for n student records. Right? And the system returns a pointer. It says, okay, if you go to this address, that many bytes are essentially the space that are given to you, right? That is returned to you. Right? Now, because it is a pointer, it is a safe programming practice. It is not necessary, but this operation, this expression which precedes the function called malloc, that is in brackets you return student record star, is called a typecasting operation. Right? So what is a typecasting operation? As a programmer, you say that whatever memory I get successfully from malloc should be considered as a pointer to, should be considered as an address to student record data type. So I repeat this, the pointer that malloc returns is an address to a certain amount of space, right? And the amount of space that is given to you is a space for n student records. As a programmer, you also specify explicitly that this space must be treated as n student records. In the C programming language, this is really not necessary. By default, it will be considered as the address will be considered as a pointer to student record. However, it also allows you to do some tricky programming here, which I will not draw your attention to at the moment. Right? So therefore, the student record star, this is a typecasting operator, right, which precedes this particular function call, right, is not mandatory, but it's something that I'm exposing you to. Right? Therefore, this pointer is now assigned to this variable example. Therefore, you can see that there is no type mismatch in this statement. That is, the data type on the left hand side and the data type on the right hand side are identical. Okay. Sometimes, because your system has run out of memory, malloc may fail, in which case example will take a constant value called null, right? And you can check if example is equal to null before you use the pointer. Right? That is a good programming practice. Okay, so what have we done so far? Let us stop and take stock. Right? So we have talked about struct, creating a new data type. We defined a new type name. We looked at what data structures are, and finally we convinced ourselves that being able to manipulate memory, to be able to ask for memory and to be able to play with addresses is very important for creating data structures and maintaining and managing data structures. If you don't do it, somehow your program has to do this, right? So in the C programming language, all the details are exposed to you. In other rich programming languages, many of these details may not be exposed to you. For example, if you go to Java, the details of the addresses and so on may not be exposed to you, to the programmer. Whereas in the C programming language, and this is what I mean, it is a very flexible and nice programming language, you have access to all the internals. Of course, you have to choose to program very carefully when you have access to many features. Alright, so now we've exposed ourselves to how MLOC works, or rather what MLOC does and what kind of statements you will typically write involving the MLOC library function call. Alright, so let us just look at some programming practices. Recall in the previous slide we defined example as an address. So now I can say example of I. Observe that this is like an array access. Now what is example of I? If you should answer this question. In other words, when somebody asks what is example of I, the question typically means what is the data type of example of I. So what are the alternatives? You may say, well, it is of data type student record. Some of you who are not very comfortable may say it is pointer to student record. Right? The second answer is wrong. The first answer is right. Example of I, if you imagine, the data type of example of I is one student record, not a pointer. It is one student record. It is same as example, which is a pointer, example, which is a pointer, plus I. This plus I says whatever example is pointing to, increase it by I units. I repeat, increase it by I units. How much is 1 unit? In this case, 1 unit is the size of your student record. So increase it by units and look at the data item that address is pointing to. Right? You have to program with this to be able to feel more comfortable, and I encourage you to do this. Okay. Then I can say example of I point dot year of joining is 2012. So this is the assignment that we saw in the first or the second slide. Similarly, I can say copy the string Narayanaswamy into example of I dot name. Now you can also use star example plus I dot year of joining. In later slides, you will also see another shortcut, right, which is equivalent. Of course, I do not explicitly mention it, I will use it, so you should figure out what it is. Of course, I will talk about it. Now, the function called free example releases the memory pointed to by example. In other words, after you've done a free, example is not pointing to anything meaningful. Right? And somehow the underlying execution environment gathers all those memory locations that you have released. And that memory can be given to other function calls that you are making or to other processes that may be running on your system and so on and so forth. Therefore, freeing is a good programming practice. On the other hand, if you do not free, then you may end up using a large amount of memory and at times even running out of memory. Therefore, as a programmer, it is good for you to analyze and imagine how memory is being utilized and release memory back to the underlying execution environment whenever appropriate for your program. Alright, here comes the third very important thing. Right? How does one use all these things in function calls and how does one return values? Right? And this is extremely important. Right? Fine. So let us look at a generic function. Right? It is find a specific item, right, and return a pointer or return its location. This is a generic function call. Right? I repeat this again. When you're working with data structures, right, one of the most common things that you will repeatedly do is to write a function that looks for a certain data item in a certain place and you will return a pointer, and this is exactly what is illustrated in this example. Find specific is the name of the function. What is the argument? Right? The argument is an address which points to student record. So you can imagine that the pointer points to an array of type student record. So I repeat, the pointer points to an array of type student record. Just imagine it. So when we write the program, you will see this completely realized. And the result of the find specific function is that it returns a pointer to student record. What is another very common data structure function that you will repeatedly write? You will say add a record to this particular data structure. That is, which particular data structure? The data structure pointed to by pointer, add a particular record and return a new pointer. So that is a typical data structure function. Similarly, you can say delete record and so on and so forth. Right? So you will find a particular pattern or find a particular value, you will add a particular record, delete a particular record, and after performing these operations, you will return a pointer to the modified object. Right? So this is a template function call whenever we work with data structures. Alright, so let us just take stock. We studied three things so far. Right? We talked about structures, we talked about type names, right? That is the first concept. Then we convinced ourselves that a data structure is something that grows and shrinks as the program execution continues, as the program executes. Therefore, as a programmer, you should put in appropriate instructions or appropriate statements to grow and shrink your data structure that you have imagined. And the next point is that, right, so just a moment. Right. So the next point, which is important, is that you need to find out what statements are relevant for you to obtain memory from an underlying execution environment. And we've seen that the library stdlib.h, the header file, provides you access to malloc and free functions. And we've seen how to use the malloc function call and all the parameters associated with it in a careful way. We will see more details of it in the program that is going to follow. And finally, we also saw what a typical function call looks like when you work with data structures. Right? So a typical function call looks like finding a particular key and returning a pointer, adding a particular record and returning a pointer, deleting a particular record and returning a pointer. Right? So this is essentially how the whole data structure area works, right? So you use certain features to say this is a new data type which is of interest to me. I want to give this shortcut name to this. I want to instantiate this particular data type. I want to have so much memory while execution to represent this data structure. And you also have appropriate methods, as they are called, function calls, to modify your data structure. And this is how the whole data structure evolves. And this is how you program to create and maintain data structures. And every data structure has an associated data type. Right? And data type is something that you design and create. Alright, so that was a summary of today's lecture. And let us now look at this programming exercise like the previous lecture. Okay, so now the program is called prog2.c, right? Week 1 prog2.c, that is not so important. Right. Now, as you can see, I have three headers which are included. stdio.h, stdio.h, okay, that is for standard input output, printf, scanf, etc. are present in this header file. stdlib.h, this is where malloc is present. The function called malloc is declared inside stdlib.h. String.h has the string operations that we are going to perform. So we have moved to the second part of this lecture. So it might be instructive for you to take a break and come back and look at this C program, though I am continuing this as one single recording. Okay, so what is this programming exercise? As in the previous lecture, the intent of this particular program is very succinctly put down. This is a program written by me to illustrate the concepts of typedef, struct, pointers, malloc, and function return values. In this example, you will see all these 5 concepts illustrated, right, at one place. Let us understand the problem statement. The problem statement is the following. The input to this program is of 3 types. The first input is an integer value n, which tells you how many records are going to follow. Then, starting with the second line up to the n plus 1th line, each line has 3 values. These values are separated by a space. The first one is a string. You can imagine the string to be the name of a student. The second one is a number. You can imagine that to be the year of joining of a student. And the third one is a single character, and it will represent a gender which can be M, F, or N, which stands for not specified. So, subsequently, the last line, so observe this, the first type told you how many records, then the number of records followed, and the last line consists of a value 1 or 2. Right? Okay, what is the meaning of the value 1 or 2? The value 1 or 2 determines the output of the program. Right? Depending on 1 or 2, the value prints out, the program prints out the record which are input, the smallest first field or the smallest second field. The program prints out that record among the n records that you have input. The first one that has the smallest first field or the smallest second field. Right? So this is the program. Let us just do an illustration before we go into the program. Right? So I already have compiled it, but so let me just run a compilation again using the GCC compiler. Right? The compilation has successfully completed without any messages. Now this is my executable that I just created. Let me run this. Alright, so let us say that there are 3 records. Now I have to input the records. Let's say Ramesh 2010, M, Suresh 2012, M, Ganesh 2014, M. Okay, now we want the record which has the lexicographically, or rather in the dictionary order, the smallest first field. In other words, I want that record which has the name which occurs first in a dictionary, in the dictionary order. So let me give 1. As you can see, this is the output of the program, which is Ganesh 2014M, and that is very clear. Ganesh is lexicographically smaller than Ramesh, which is lexicographically smaller than Suresh in the dictionary order, in the English dictionary order. Let us run one more run of this program. Let us say again there are 3 fields, which is Ramesh 2010, male, Sita 2012, female, Suresh 2014, male, and let us say I want that record which has the smallest second field. In other words, you want a student who joined the earliest. As you can see, the output is the person who joined in 2010. Now, clearly, you can immediately imagine multiple applications of this programming exercise. I don't have to tell you. If you have used any software, for example, if you have used an Excel spreadsheet, this is a standard feature where you have some data which occurs in columns and then you ask to sort according to the first column or the second column or the third column. Right? So if you have not done this, please go back and try this. Use Microsoft Excel, right? Or there is also OpenOffice which also provides similar features. Go ahead and use it. Create a few columns, right, of data. In first column you can put in names of your friends, the year of birth of your friends and the gender of your friends, and you can ask the spreadsheet program or the spreadsheet software to sort based on the first column or based on the second column and so on. So this small programming exercise that I have written in C is something that illustrates such programming exercises. Okay, so you've seen the input-output behavior of the program. I hope the input-output behavior is clear. Let us go back to the program itself. All right. Let us look at the new data type that we have created. Right? Here, as opposed to what I have done in the lecture, I have said that I want to create a new type name called student record. Type def, the consequence is a new type name called student record. The student record type name is a shortcut for struct student detail. Let me say this again. Type def results in a type name called student record. Student record is a shortcut for struct student detail. Okay. And what does struct do? Struct says that struct student detail is a new data type whose fields are name with 20 characters, year of joining is an unsigned integer. Right? As a programmer, you are explicitly stating that this is an unsigned integer, and you are giving a variable called gender. You have a variable called gender which stores a single character. Right? So therefore, this is the new thing. We are going to create a new data structure. The elements in this data structure are going to be of data type student record. Okay? Are going to have type name student record. Student record is the same type as struct student detail. Right? That is, student record is a shortcut for the type struct student detail. Every item of this particular data type has three fields which are name, year of joining and gender. The first one is a character array, second one is an unsigned integer and the third one is a character. So this is the first thing that you do when you want to write a program. You understand what kind of data you are going to manipulate, arrange them into appropriate data types. You create a data type, give appropriate data type names so that you can comfortably use them. That is the first step, and we have done it. The next step is to, like in the previous lecture, define this function prototype which says that find specific is a function name which is going to take a pointer to student record, one integer and another integer. We will see what these two integer arguments stand for, and it returns a pointer to student record. Okay. So now you have defined your function prototype also. Alright, so let us quickly go through the things that you would be familiar with by now. Right? Okay, this is the main function. It returns an integer value. It has one integer variable called number of records. This is a variable which gets its value from the input. Operation code, right? This is the code that you key in the value 1 or 2 that you require to identify the record, whether you need to find the record which has the smallest name or the record which has the smallest year of joining. Right? That is stored inside operation code. Then you say that students is a variable of type pointer to student record. I repeat, students is a variable of type pointer to student record. Similarly, student of interest is a variable of type pointer to student record. Right? Then I have int I as a temporary variable. Okay, so this scanf, what does it do? It reads the number of records, the first reading from the key. You can ignore this flash stdin for now. We'll talk about it a little later. Okay, then comes the third major concept of the day, how to use malloc. I ask the system at runtime to allocate memory, which is size of student record. Right? Okay, so therefore, there is a missing detail here. I'm going to make this change right in front of you here. Okay. As a record, this must be number of records star size of student records. Now it's interesting that it still worked without this. So let us just understand what we are doing. Right? I'm going to ask for memory, which is number of copies, number of records of student record, like we saw in the slides, and then this is a typecasting, and students is going to contain the address of the memory region that has been allocated to you. Right? So what does malloc do? Malloc reserves a certain amount of memory for your program, for your execution, and returns a pointer to the first of those memory locations, and students contains that particular address because of this assignment. I hope this is clear. Now what do? We go to the input, right, and read one after the other a string which corresponds to the student's name, an integer which corresponds to the year of joining, and a character which corresponds to the gender. And observe, I am using a single scanf which is reading 3 parameters separated by a single space. I repeat this. This scanf statement reads 3 data items. One is a string, right? It goes into name. The next one is an integer. It goes into year of joining, and the last one is a character which goes into gender, right? And each of which goes into the ith record in the data that in the memory that has been allocated to this execution by the system. It goes to the ith record, the ith student record in the memory that has been allocated because of this malloc function call. Okay? That is what this loop does. Okay, next what we do is we read the value for the operation code. The next sentence or the next statement essentially says that if the operation code is not 1 or not 2, return a -1. Right? Fine, essentially the operation code is invalid, no sorting, no operation can basically be done, you return a -1. Right? That is, the program exits by returning a -1. To whom is not important for now, it does return a -1. We will worry about the value -1 is returned to whom a little later, or as you program more and more, you will become more comfortable with this thing. And especially if you work in the Unix programming environment, this becomes very clear. Alright, now comes the function call find specific, which we make. We send the student's pointer to the function. We send the operation code, which is either 1 or 2, and we also give the information of the number of records that we have in the students array. I'm going to call the students pointer now also the students array inside this loop. They are equivalent, they are one and the same. Okay? And the return value, that is, this is a pointer, student of interest is a pointer, right? And it points to the record in the student's array which has the least value of field 1 or field 2 as given by operation code. That is what is put down in this remark. And this printf statement finally, the printf statement below prints this whole thing. Right? Prints the 3 data items, which is what you have seen when the program ran. It gives a /n before printing and it gives a /n after printing so that you can see this clearly. Alright, so let us just take stock. What does the main function do? The main function has demanded a certain amount of memory from the system. After reading the number of records as input, it has asked for a certain amount of memory. Then it has populated the memory with appropriate values by reading the input. Now it takes the operation code. If the operation code is invalid, the program will exit. If the operation code is valid, then control will be transferred to the find specific function. Now let us go to the find specific function. Okay, after the find specific function returns a pointer to the appropriate data item, this printf function prints the 3 values which are of interest. It's a very simple program conceptually, but it illustrates all the different important concepts which are necessary for us to create data structures throughout this course. Alright, the find specific function is very simple. Right. The local copy, the variable name is called local copy. It's a pointer to student record. This is the field that you are interested in arranging your data type by data by, that is, you want to look for the appropriate record for which the field value is the smallest, and this tells you how many records are there that you must process. Right? And the return type is a pointer to student record, as we have been saying this again and again. Alright. Okay, so I and j are temporary variables. Actually, j doesn't get used, right? Temp is also not used here. Instead of temp, I'm using a new variable called rec_return, which is a pointer, right? And this is a pointer to student record, right? So this is essentially the short form for the value that is going to be returned. This is a variable name. Okay, initially rec_return is set to be the local copy. That is, it points to the first record in your data. Now let us just look at this one. So here is a loop which checks each of the elements, right? If the field is 1, it does a string copy. It does a string compare of the string which is available or the name which is available in your rec_return and the string that is available in local copy of I. It compares the 2 of them. That is, strcmp compares these 2 strings. If the first argument is lexicographically larger than the second one, right, then the return value is 0, is greater than 0. Actually, it is a 1. And if the first argument is lexicographically smaller, then the return value is a -1. If they are equal, then the return value is 0. Right? Let me just repeat. strcmp is a library function in string library. It takes 2 arguments. This is the first argument. It's a string. This is the second argument, which is another string. It compares the 2 of them. If they are equal, the return value is 0. If the first argument is smaller than the second argument, the return value is -1. And if the first argument is larger than the second argument, then the return value is +1. Okay. So if the name in the current smallest, which is your candidate, is larger than the name in the local copy, the ith local copy, then you say that rec_return should contain the address of the ith local copy, which is what is here. Okay. So observe there is no type mismatch here. This is a pointer. Local copy is an address. Incrementing an address by I units is also an address. Therefore, there is no type mismatch in this statement. I hope this is clear. This is done if the field is 1. That is, you want to do this whole selection according to the first record, first field in the input records. On the other hand, if you want to do the selection based on the second field, right, that is just an integer comparison. You compare the year of joining with the year of joining right? That is, you compare your current candidate year of joining, which you believe is the smallest, which you have stored, right, with the year of joining in the local copy of I, that is in the ith record. If the current year of joining is larger, then you update the appropriate record address, right? So which is something that you have already seen in the previous case. So observe that the field is used to perform two different types of comparison. Here you perform a comparison of two strings. Here you perform a comparison of two unsigned integers. Okay. After now processing this whole size number of records, definitely you would have found the record with the smallest appropriate field, and this value is returned to the main function, and then subsequently the value is printed. So this completes the whole description of the code, and just because we made one compilation change, let us just complete the compilation. Right, the compilation goes through. Let us execute it once. Let us say there are 5 records. Right? Ramesh, 2012, male. Sita, 2008, female. Ashwin, 2017, male. Kavya, 2009, female. Mahati, 2020, female, right? So now we have input 5 records, and let us try to sort it according to the first field and get the smallest value. Obviously we get Ashwin, right? All right, so it is also possible to test this program like in the last lecture by giving erroneous inputs and seeing how the behavior is, but in the interest of time for this recording I will not do it. You're welcome to write your own program and perform such tests to mainly understand that it is not possible to control the input that is given to a program. So it is very important to program in such a way that as much as possible you can capture meaningless inputs. Alright, so we are almost at the tail of today's class, right? So let us just look at what we have done. We've studied 3 important concepts with respect to the subject of data structures. The goal of data structures is to write programs where the instructions or the statements enable data structures to shrink and grow based on the input environment. That is, the set of inputs that are given to the program while execution. For this, we convinced ourselves that being able to ask the system for memory at runtime is a very important feature, and we saw there are library functions which do this. We also saw that data that comes to us when you program may be of different types, right? And therefore we constructed this example of a student record data type, right? And we saw how to define a data type, and then we also saw how to give a shortcut to this data type name. Finally, we saw the simple exercise which brought in all these concepts together, which picked up the least value satisfying a certain property from an input set of records of a particular data type. So let us complete the lecture by going back to the therefore this brings us to the end of this lecture, right? And in the next lecture we will work with recursion. The next lecture we will work with recursive functions. Specifically, we will start off with simple recursive functions for factorial and We will also write recursive functions for the towers of Hanoi problem. So thank you very much, and I hope you enjoyed the lecture today.